This is the simulation model we're going to use to address uncertainty, and the main elements of the model are the following ones. First, we have this facility tab, okay, where we can see the elements in our line. We have stations 1 to 4 and stations 5, 6 to 7 that do not exist initially, but we have them here to evaluate when we change the number of stations to 5, 6 and 7 whether the results are worth the investment of having those stations or not. In addition to that, we have another elements, parts arrival and shipped. You need to take care of them because they just introduce parts into the system and get them shipped to the customer or wherever they are shipped to. And we have a rejection element here because sometimes you might be introducing way too many parts into the system and they do not fit in, they have to be rejected. And we have elements of information regarding every station to see how they performed, how much time they were busy, stopped, blocked or failed, and the time in station, on average for the different parts that are in this station, and the same for the other stations. And finally, we have two items here, which is a cycle time, which we get the average, which is on average, which is the time in between two parts that come out of the line, and the average hourly production. Okay, and this is the elements we're going to see, and we'll see parts, which are these triangles here, the amplifiers moving along the system, and we'll get the results that we might expect from the real world if we do what we are exploring here. And we need to configure the behavior of the line of the model to foresee how the line will perform, and that is done in two different parts of the model. First, we have here the properties we can change. First, we have the number of stations. If we use 4, we will be using only 4, and we have other items I won't comment now. Okay, and the relevant things here are the number of stations. Okay, the information regarding each station. For example, we have station 1, and we can change the number of positions. If we have 2, that means that we can assemble 2 amplifiers at the same time in station 1. That is not the case at the beginning. We have only 1. The same for station 2, 3 and 4. We can change the number of positions, and we can also change the buffer capacity, the input buffer capacity of every station. We don't have that for station 1 because we assume that we have an infinite capacity in that station. So we can change both buffer capacity and the number of positions. If we change this number 4 to 5, we would get an extra set of rows here for changing the information regarding station 5, and the same if we type 6 and so on. So let's go back to 4, and we're only using the original 4 stations we have prior to introducing any changes in our system. And the second element of input data that CBO uses is this table here. If you go to data, you have a table which is pretty much the one we had in PowerPoint, which has the list of tasks and the mean time per task and the variability. Okay, and we have an additional column which is the assignment of task to station. So we have station 1 is where task 1, 2, 3 and 5 are performed, and that is why we need to have this to have a realistic representation of our system, and in particular of processing time, so that Simio, I already created some processes here, but that's okay for you. What does, sorry, I clicked on results, I want to click on data. What it does, it goes through this table every time we have a part, an amplifier that has to be assembled into the system. It comes here and generates a set of times that are consistent with this data, and that are actual times that might happen in the real world, and those are the times that will be used for every amplifier to remain in these different stations. So if we run the model, we click here in this button run, what we see is elements moving along the system. Okay, you can change the speed here. Okay, the larger the number, the faster it goes. Okay, as now. or if you click just one, it slows down so that you can see in detail what is going on.